I remember when first joined Microsoft to write C++ code 3 years ago. At first, I was excited. Oh, C++ also has automatic type deduction. That's cool. Then scaled. Why is there a pair of square brackets, followed by a pair of regular brackets, then followed by a pair of curly brackets with some code snippets inside? What is that? So I got confused. Wait, this is not the C++ I learned from textbook in college. That is when I learned the existence of C++11. At the CppCon keynote, Beyond's Josh Job reminded us again that we are all students. The world is moving on. It is moving on too fast for any of us to keep up with everything. We have to be students, basically all the time. Otherwise, we fall behind, and we become part of the problem. And we are all teachers. We give advice, that's teaching. We better give good advice, give useful advice that would bring us forward. Think about what it is you want to achieve and work backwards from that. Don't start with what we have always done or what is easier to get started. Modern C++ is not C, C++98, or our decade-old coding rules. Inertia is the enemy of good code. Current practice is often what was fashionable 10, 20, or 30 years ago. The purpose of good teaching is get good ideas and technique into the other person's head. So what is modern C++? We aim for completely type-safe and resource-safe code. A project called C++ Core Guidelines, launched 2 years ago, gives a more concrete answer to that question. But there are over hundreds guidelines. Memorizing them all seems impossible. K. Gregory picked out a collection of guidelines and talked to us about them. What comes to your mind when you see these two functions? What's the difference in the implementation? I need to make changes in the first function. Should I also change the second? Well, there is a choice. Prefer default arguments over overloading. What would the values of a, b, x be like? Is it 1, 2, and 3, or it is 1, 3, and 2? Define and initialize member variables in the order of member declaration. Don't make your code lie. Okay, this function takes a namespace, a folder. Now id control false true. Keep the number of function arguments low. It lowers cognitive burden and recall effort. Did anyone ever add const cast to an object just to shut up the compiler? Casting away const of the value returned by a const function allows the function to change anything in the instance. Now your header file is a lie. Don't cast away const. This one we are all familiar with. Never transfer ownership by a raw pointer. In the 2017 universe, probably the best thing to do is to return by value if you don't mind a copy, or take by non-const reference and change it. You can also return an appropriate smart pointer. Do you ever want to have the same name for different enums? Did the so-called helpful conversions to int ever hurt you? Prefer class enums over plain enums, so that names can overlap and implicit conversions to int do not happen. Are you sometimes tired of all the null checks? Do you want to prevent any runtime null pointer exception during compile time? Declare a pointer that must not be null as not null to avoid dereferencing null pointer errors. It can also improve performance by avoiding redundant checks for non-pointer. Avoid lossy, narrowing, truncating arithmetic conversions. The guideline support library offers a narrowcast for specifying that a narrowing is acceptable and a narrow that throws an exception if it would throw away information. It is encouraged that everyone go bookmark the CPP core guidelines on GitHub. Search the guidelines next time you have a decision to make. After 2 or 3 good hits, try reading the whole thing. And consider using a checker to let you know if you are breaking some. One of my favorite quotes is, C makes it easy to shoot yourself in the foot. C++ makes it harder, but when you do, it blows your whole leg off. Other than the C++ core guidelines, what are the other tools that can help us from hurting ourselves? We can use formatters to follow code style. There are tools that could generate code for us. Learn to use code analyzers to give you compiler warnings and some extra checks. Modernize your code with refactoring tools. Check with unit tests. I want to use this popular image to end this video. Let's keep learning, applying guidelines, using tools, and write better code.